Greetings, math fans. All right, so these are a few more problems that I believe it's just a good idea to study for the final exam. To understand if I give you guys a graph to come up with an equation, or if I give you an equation to come up with a graph. Okay, so and even some more talking about domain and ranges of some of the different graphs. Okay, so let's, like I said, I made this up a little while ago, and let's kind of go through it. Okay, so the first one is I give you a nice little graph here. And if you would actually just guess without even looking at the multiple choice, you would tell me that is a positive cosine graph. Now the problem is you got all this extra stuff here. Okay, so you've got all this right here, and so that's not one of your choices. Not just that would be too easy just to tell you it's a positive cosine graph. So there's definitely a shift of a graph, and so what I'm going to do is if I look at pi over 2. That's a shift of a negative sign graph. Do you guys agree? Okay, so just like if you guys remember this kind of problem, y equals x plus 2 squared plus 7. Okay, so this is my vertical shift, the set plus 7, and that x plus 2 means I move to the left 2, right? If it's positive, you move to the left. If it's negative, you move to the right. So kind of looking at these different shifts, the phase shifts, if this was a negative sign graph, which I don't have a negative sign graph, so that kind of gets rid of that one. So let's kind of ignoring that one. There's nothing that's negative. So even starting here, that doesn't work because that's a negative cosine graph. So really, we're going to shift. It's going to be something with sine. Okay, and if you would kind of continue this graph on, that's probably negative pi over 2 here. So it's shifting to the left pi over 2. So that means it's going to be something like x plus pi over 2. And it's a sine graph, a positive sine graph, x plus pi over 2. So D is your answer. Okay? So just kind of a process of elimination, kind of thinking a little bit of what's going on, and you should be pretty successful in figuring out what graphs we have. Okay? All right, so let's move on to the next one. Okay, so looking at the next one, right away you can see it's going to be a secant graph or cosecant graph. Now, just kind of noticing here, math fans, it's if I would draw a dotted line here, because that's really what's going on, it's definitely shifted down 1. So this one is out of here. B is out of here. This is process of elimination. And this one shows an amplitude of 2, and it doesn't have an amplitude 2. It has an amplitude of 1. So this one's out of here too. So really, I've narrowed it down to, is it a cosecant graph or a secant graph? And basically, if you kind of just sketch it with, with a graph here, so you know it's touching it here and it's touching it here. So the graph is going to, kind of go like this and like that. So what we're going to do is, it's like, well, what graph starts at a maximum, if you want to look at it that way? And you guys should say, well, that's a cosine graph, and it is a cosine graph. So cosine goes with what? Goes with secant. So that's your answer. Okay? So it's kind of just making a good sketch, and you're pretty successful. Okay, let's move on to the next one. Okay, so you look at this graph and you're like, well, let's see. These are all the solutions here. The A, B, C, and D are all positive. So there's nothing that's going to reverse it with like a negative cotangent or negative tangent graph. And so you guys should remember, I taught you guys this back in the day, all students take calculus. And so the tangent graph always looks like this. Always starts kind of in the bottom left, and the cotangent graph always starts in the bottom right. Okay, so I look at this graph and I can definitely tell this is a tangent graph. Okay, so this is definitely a tangent graph. And then it's definitely, if you look at this point right here, guys, right, that's like the middle point, and it's shifted up 1. So that's interesting. So that actually kind of just, even without doing anything else, this kind of tells me which is the answer, right? The answer is C. Okay. Now, if you look, see the x minus pi over 2. So that means it's shifted over to the right pi over 2. And sure enough, the graph usually is between negative pi over 2 and pi over 2, right? And then it looks like this. And so this is shifted over now shifted over pi over 2 between 0 and pi. And so that's why it's x minus pi over 2 shifted over to the right pi over 2. Okay? So again, kind of just be good with it when you're looking at these graphs, and you should be pretty successful. All right, so now a couple of them are just asking you guys about range and domains of these different functions. So let's take a look at these guys. Okay, so the range of this function, and just got to remember, you basically, this is kind of like your baseline right here, the 3, right? That's your vertical shift. So if you're at 3 and the amplitude is 2, doesn't matter if it's negative or positive, you're going to go up 2 and down 2. So that means if I subtract to it, your range is going to be from 1 to 5. Okay, that's not bad. All right, and then so on to the next one here. It says, what is the domain? Well, again, this really doesn't matter what this is for, especially for cosine graph. If it's a domain, it's negative infinity to positive infinity. Okay, that's pretty easy. Okay, so let's keep going. What is the range of this one? Well, if you guys remember, range for tangent graph is negative infinity to positive infinity. Okay. Now we got a cosecant graph, and remember, a cosecant graph, you basically graph the sine graph, and then it goes above it and below it. So if this was actually a sine graph, it would be starting at 3, go up 2 and down 2. So it would be from 1 to 5. But because it's a cosecant graph, it's below 1. So this, my actual range is going to be negative infinity to 1, bracket, union, 5 to infinity. Okay, it's not bad. And a couple more here. List 3 asymptotes. So remember, guys, when you're looking for an asymptote, you're basically saying where is cosecant undefined, or in this case here, where is sine equal to 0. That's the easiest way. So where this is equal to 0, cosecant is undefined. So let's do that. 3x minus pi over 4 equals, well, where's sine 0? Sine of 0 is 0. And here's another one. 3x minus pi over 4 equals, so at pi, it's also undefined. So I add pi over 4, so 3x equals pi over 4. Multiply by a third, so x equals pi over 6. That's an equation because it's x equals of an asymptote. And, oh, I asked you for 3 asymptotes, so we're good. So I'm going to add pi over 4. So 3x equals 5 pi over 4. Multiplied by a third, x equals 5 pi over 12. And we do 2 pi. So I can say 3x minus pi over 4 equals 2 pi. So I get 3x. If I add that, I get it's 8 pi over 4, so 9 pi over 4. And multiply by a third. So x equals 9 pi over 12, or 3 pi over 4. So those are 3 different equations of asymptotes. Okay, that's pretty easy. Okay, and then the last one that we have here is list 3 asymptotes for y equals 3 minus 5 tangent. So kind of the same thing. Where do you have a tangent? Where is tangent undefined? And you guys should know the tangent is undefined at, negative pi over 2, pi over 2, right? Because tangent 0 is 0, tangent of pi is 0, but these are all undefined. And we'll say 3 pi over 2. So you set each one of those equal to those values. So we get 2x minus pi over 2 equals negative pi over 2. 2x minus pi over 2 equals pi over 2. And 2x minus pi over 2 equals 3 pi over 2. So we're going to add pi over 2. So we get 2x equals 0. So x is 0. That's one equation. And this one's 2x equals pi over 2 plus pi over 2 is pi. Divided by 2, so x equals pi over 2. Undefined there. And I add pi over 2, so 2x equals 4 pi over 2, or 2 pi divided by 2, x equals pi. Okay, so those are 3 different equations for asymptotes. So that was kind of a quick video. It's about a 10-minute video just on more graphing. But again, just spend a little time on that and be careful and get the graphing problems right on the final exam. All right, my fans? That's it. You have an outstanding day. Adios. Goodbye.